Thank you very much and for the introduction, and it's really a conversation, right? And I really liked that I have got this invitation on the second day. The reason being, I'm a physicist by training, and we always say that innovation happens by standing on the shoulder of giants. So yesterday, we have been listening to many fantastic talks. Even today, the speaker before talked about GenAI. My first disclaimer is, whatever you are going to listen, it has nothing to do with GenAI. It's not prepared by GenAI. It's human intelligence. Okay, the next thing is, you see the title of my talk is, I'm exploring the second line, which is little miniature data, science, and engineering. And yesterday, we heard about from Dr. Laks Raghupati, my colleague from Shell. He talked about B2Bs and personas. So here, I'm standing here talking about data, changing my persona to science, and then changing my persona to engineering, right? Throughout half an hour, next half an hour, we'll do that. And nonetheless, I also happen to have a professorship position, adjunct professorship position. That's another persona. And with that persona, what comes for free is that I ask questions. I don't allow you to ask questions at the end. In between, I'll be asking questions. Okay? And normally, I don't say that it's a deal. It's a deal. Because that's my last persona. Okay? Thank you very much. Going forward. Yes. First question. How many of you do NLPs? Yes, quite a handful of people, right? And when you talk about data science and AI, it's all about getting insights from the data and eventually getting into the wisdom, right? Now, my next question to the NLP scientist and engineer, that if you want to run an NLP model in the disclaimer that you see, what do you get, right? This is an unstructured data in the terms of the data science. This is unstructured data. What you get, the first insight that you get, probably the AI tool will not give you, but the human intelligence will tell you that whatever I'm representing, it's my view, not my organization's view. That's the first insight. And what wisdom you get, eventually we all target for the wisdom, right? The wisdom is, don't make any investment decisions based on what I take. That's the wisdom that I want you guys to take it from this conversation, okay? Now, I started my journey in undergrads, early 90s. This is the picture, and I'm a physicist, astrophysicist by training. The first is the picture of Pluto, 1994, when I was in college. And this is what we see now. So that's the advancement has happened in the technology space, and it has something to do with the digitalization, because the first one was not a digital image, right? Somehow some signal that we received from some of the stars, and this is the image of Pluto. And over the years, things have changed. 30 years, things have changed. And so the software engineering, right? This is what used to be. How do you build the software? One straight waterfall process, right? And now we moved into this. We talk about cycle, DevOps. We talk about continuous integration, continuous development. We'll come back to that when I'll get into my engineering persona. But here, let's first see what artificial intelligence talks about. This is I picked it up, the definition from the dictionary. And what I highlighted here is, I see, it's actually we're trying to do some computer-based heuristics to imitate nature and to understand nature, right? And what do we see it? In the next few slides, we will see that what do we actually mean. So in Namma Bengaluru, our Bangalore, right? What we are proud of is weather. Second is traffic. Maybe it's notorious, but it's traffic. And I have a 14-year-old daughter. So I've been trying to teach her when she was young that how to cross the road. There are some rules, just like that we train our models, right? I wanted to train my daughter how to cross the roads. And this is very straightforward, right? You see the signal on this side, signal on that side, it stops. But when it comes to scale, this is what happens, right? How do you cross the road? Right? That's the challenge, right? They're into build intelligence, right? So I think that's the same philosophy as a physicist that I follow, that how do I imitate nature based on the data? And the problem is when it comes to that scale, this is chaos, unstructured, right? We talk about unstructured data. So what do you want from this? How do you build a model so that Elon Musk, Tesla can drive it here, right? How do you do that? Yes, right? So we apply some heuristics, some rules, some principles, and at the end apply human intelligence to do this. Right? This is what we do. The same thing we do with our models, with our data, with everything else, right? Now, I read a lot. So this is a book by a famous Nobel laureate, Ilya Prigozhin, and it talks about how to extract information from, how to basically get insights from a stochastic information. And in this field of data science and AI, everything is probabilistic, right? So we talk about stochastic phenomena. And why this is important? Because these are the steps that we typically follow, that we start with data science, which is descriptive in nature, we describe, and then we try to predict something. We heard about predictive analytics and stuff like that, and eventually we get the wisdom and get a prescriptive analytics, right? So that's the perspective of data science that we get in the context. So if you are still doubtful, with my professorship persona, let me give you a real life example, another one, right? And I really like that. When I talk to my students, I think that if this is what I learned from my professors. So think about the great example of talking about data to knowledge to insights to wisdom. A very real life example, right? We all know tomato, right? So we go buy tomatoes from the vegetable shop, but tomato is not a vegetable, it's a fruit. Right, yes, tomato is a fruit. That's the knowledge, right? But what the insight you have, if you know tomato is a fruit, even then you don't put that in the fruit salad. That's the insight, right? And you know what the wisdom is? The wisdom is you don't care. Tomato is fruit or a salad, make a Bloody Mary out of it. Right? That's the wisdom. And this is what I'm trying to do in the next 20 minutes, right? Okay, so what do you need? Businesses, right? We have been listening, we heard our GM Karthik Ranganath talked about different kinds of applications in the space. We heard about Lax Raghupati talking about data science, applications of AI in the B2B space. And we have Prakalp, who talked about very deep dive, very deep technical with mathematics. I'll be showing some mathematics, by the way, okay? Deep dive in the mathematics and talked about how we do reservoir modeling, right? But at the end, we are a business house, right? We need to make money. So we need to basically get insight. So what we get is this. Try to focus on some part of the data, try to see what is the meaningful data that we can get. But the problem with data is we can represent the same data the way that I want to, you want to, right? That's the problem with data. And we need to be careful. In this space, 2023, we need to be careful what we do. Because we have tools like Gen AI, we have tools like many other sophisticated libraries which will do just like that. But we need to be sure that what we really want to get out of the data, that is very important. You need to know. Again, another book which is one of my favorite, right? It's very easy to lie with statistics, right? And as a person, I write blogs. And this is the term that I really like. It's very easy to manipulate with statistics, and I call this statisplation. And the example is here, right? Because there are problems in sampling, there will be bias in numbers, and depending on who interprets, right? If the party A interprets the political situation based on some data, they interpret their way. If political party B interprets the same data on their way, they interpret differently, right? That's the problem with data and whom to trust. You read one newspaper house, you get one perspective, you get another newspaper on the same data, you get another perspective. That's why I always say that statistician is the word. And the example is, if I want to predict the pattern of cell phone usage based on the data that I have from 2005 to 2010, this day will be failing miserably, right? And the second part is, again, we talk about gender equality, we talk about diversities and everything, right? They are social, keeping the social part aside, right? It's very difficult to do a modeling on the gender ratio versus the income ratio. The same thing happens that we are seeing that the exit poll results in kind of election, that is very different than what you get, right? But even saying all these things, why do we care? We means Shell. We are not an oil and gas company, but we are an energy company, right? We have been hearing about this. So that's the perception that we are going to change. And if I am not able to do the justice, please feel free, the other personas that I have, who are my colleagues in our booth next door, they'll be able to take you through, right? So next question is, why do we care? We care because if you happen to be in their talk, that keeping the other businesses units aside, right? If we want to take a decision that where to drill the next well from our exploration based on some data, how do you do that? And then, if I have some data based on some history, right? Last 10 years from a location that I know, this location is producing this much of barrel of oil every day, every month, every year. Can we predict what's going to happen? What will be the production rate in next 10 years, next 5 years? That's the question that we want to try. And for that, let's introduce data science now. So there are two parts, data and science. Data is data. And what the science is coming from. And that is important to make these decisions, because when we talk about exploration, geophysics, exploration to find out where the oil pockets are, we need to understand the geology. And this is not like you go to a doctor and do an ultrasound of your belly. It's not like that. So it's not possible all the time. So we need to rely on data and do this kind of modeling, right? And this is typically a reservoir looks like that. If I expand some part of the small pores, we see this is an extended version. So I basically have gone from an X-ray to MRI. Things are exposed below the subsurface, right? And actually, from a scientific perspective, the oil resides not just in water bottle, right? It's actually stick to the rocks. And we have mechanisms we call primary oil recovery, secondary oil recovery, tertiary oil recovery, different kinds of physical mechanism, and you extract the oil. And when you extract the oil, we collect data. And that data, we do the modeling, and then try to see what's going to happen 10 years down the line, right? Now, again, very simple mathematics. This is, we all know, right? If we give you x, if you know the form of f, you know what is the form of y. Y is equal to fx, standard, right? But do you know this? If you know y, do you know what x is all about? If I tell you the end results, can you predict that how we are arriving to that results? Probably not. So it's equivalent of pictorial representations, right? So this is the oil production, the left-hand side. Right-hand side is the information from the geology and the data that we get, right? And in terms of explorations, we call this, there are millions of unknowns, millions of parameters that comprises your data space. And at the end, what Y has, it's a few hundreds of observations. Means this production oil is giving you this barrel of, this is the amount of oil that you are extracting from this well, this is the rate from the other well, and things like that. And again, a mathematician and a physicist had, that persona tells you that the best model is the simplistic model, go for or comes razor. And why this is important? Because this is the number. If you have 10 observations and 100 are unknowns, this is the combinatorial sets that you get, the first row. But if I just double the observations, double the unknowns, the data explodes. And how do we apply an optimization problem to solve this? At the bottom line, it's an optimization problem in the language of mathematics, right? How do you do that? So let's say, I'm not going into too much of detail. Yesterday, my colleague Prakalp has gone into details, but I just show you one page or glimpses, right? This is how a pictorial representations of the grids of the oil field, right? And all these things, these are the locations where we actually drilling, we are getting the oil from. And we have what we have. Basically, we try to do an optimization problem. This is the only mathematics page. Trust me, I have no other mathematics. This is the only page, right? So we basically write the objective function and then try to optimize that, try to minimize that. And the problem is, this is not a situation where we have one global minima. There are multiple local minimas. And when you have multiple local minimas, your mathematical methodologies like gradient descent, which is probably the most popular thing, very deterministic way, that doesn't work. We basically apply different kinds of data-driven machine learning techniques, right? Starting with different kind of stochastic optimization problem. And we try to solve this. And ultimately, what we want that this is the way that we recover. All the recovered way, and then this is the chart, right? So up to 2010, if we have the historical data with all these observations, we try to do some predictive modeling, right? That's the wisdom that we wanted to achieve from the data. Right? Now, next thing is, the problem is when the data scales. Now we talk about 200 observations, 200 unknowns, 20 observations. And then we still have a handful amount of data which you can actually load into your computer's memory. But what happens that in the seismic processing, if you wanted to do exploration below the sea, there are techniques, right? So there is a ship going, we basically put an ultrasound that reflects back, and then we try to do an inverse modeling. This is the same principle that we apply that when you do ultrasound, right? The physician will insert an ultrasound, it reflects back, and then we do a reverse imaging. The same kind of techniques that we apply for the subsurface. And this page will give you some idea about what kind of data now we are talking about. So your computer has a 64 GB memory, right? And you have 100 terabytes of data. How do you solve the problem? How do you load the entire data set to run your model? Right? So that's an engineering problem. That's not a data problem. That's not a science problem. That's not an engineering problem. And at the end, what we see, this is the imaging that we receive. After we've done the ultrasound, we do the image reconstructions, right? It's the inverse problem. And this is another way of grayscale image of these reconstructions. But this is still the data. How do you understand the physical phenomena? Because at the end, in the AI model, in the definition, if you remember what I have shown, that you are trying to imitate nature, right? And the heuristics really works, and your understanding happens better if you have a visualization, if you can visualize the data. This is typically the visualization. This is basically how the core looks like. And we have a seismic explosion happens, microseismic, seismic explosion happens. Now we need to understand how the wave propagates, right? We always see the aftermath after the earthquake, but what actually happened, that is important to know, and that's why visualization is important. Based on whatever data that you have received, we create the visualization. And this is actually the real-time visualization that we see after we have done all this model, where the backbone is data, and we apply the physics principle, and we apply the engineering methodologies to create this, right? Okay, now let's move a little bit from only the traditional oil and gas to something else, right? Because if you heard yesterday's plenary, Karthik mentioned about energy transitions, that we are transitioning ourselves from an oil and gas company to an energy company with a very different focus. And this has typically some glimpses of the areas that we work on, and it's dominated by data. Trust me, it's dominated by data, and it's explosive. The data explosion is happening as we speak, right? And this is again a picture I wanted to show you. This is an image of a real oil and gas plant, the refineries, right? Trust me, when you see this plant, if my engineers wants to take a decision that when this equipment is up for maintenance, how do you do these days? we typically rely on wisdom. And there are many places we actually cannot see what's happening inside the pipe. Nobody can go and see, right? You have to based on data. That's why you have sensors, we collect the data, we build the model. And with this complexity, probably you are getting this dimension that why things are so complex. If you are still not able to get that glimpses that why things are so complex, I request that please come to our booth, talk to our experts, our team. We'll be give you some idea, right? Okay, now let's me move into my engineering persona, right? Purely, so what you have talked about so far is you have data, you have science, you wanted to scale, we bring together the engineering capabilities, right? So now, once you have the data, how do you make sure that we make the data available to my data scientists and AI engineers and to the business, right? These are typically the steps. But still, something can go wrong. First thing is we call this, the model can be wrong, can be a model drift, can be a data drift, can be a concept drift, right? Think about 10 years back, I used to receive emails from Analytics India magazine saying that I am doing this, I am doing this. Sorry, don't misquote me. I really am very impressed with the show. That's why I'm quoting you 10 years back. If you have sent me this email, I will immediately mark that this is spam. And then there is a spam filter which will keep running on it and saying, this is spam, this is spam, this is spam. If I don't modify my model, there's a model drift. And if I keep used to doing that, and if I keep the same email filter, I shouldn't have been here today because I have marked already this as a spam. That's the model drift, that's the data drift, right? And this is very important from our perspective also. We need to continuously refine our data sets, our model, and the way that we do things, right? So in terms of deterministic way, when we learned mathematics, when you solve higher order equations, we used to call this as these are all higher order terms that we neglect. But now it's time from the data perspective that we can't neglect the higher order terms anymore. We need to keep adding them here and there, right? Because for us, accuracy is important. I cannot afford to say that this machine is up for predictive maintenance probably between 10 days and 15 days. That probably doesn't work. I need to be deterministic. And to be deterministic, I need to be very accurate, right? Okay. Again, if you are not aware of these terminologies, trust me, this is the mantra that when you develop software, right, the software has to be reliable, the software has to be available, and software has to be serviceable. These are the three key elements based on what the software industry is standing, right? Now we have the data, now we have the science, now we are bringing together software to make sure that the end user can use it. Because for the end user, what really matters is how reliable the software is. If I am running something on my iPad, something on my tablet, the field operator has to have that confidence that yes, I can rely on this, right? Now when you do that, these are the two terminologies again in the computing world that we talk about, right? We always go for a low latency, high throughput kind of solutions, right? And this is typically an example that what we mean by throughput and latency, right? So we have many offices in Bangalore. We have another offices in Houston. I have taken just an example that if I have to fly 15,194 kilometers through a jet, if I take a Sukhoi versus if I take an Airbus, I probably reach Bangalore to Houston faster, right? But think about the differences that we have between latency and the throughput. This is very important. When you build a software, when you deal with data, when you deal with different kind of analysis and all, these are all important, right? And why the next step, why this is important is when you are building softwares, we talked about infrastructure as a service, platform as a service, software as a service, and your application actually sits on top of that. If you want to make your application singing and dancing, if you want to rely on reliability, availability, serviceability, you need to understand this. But the complexity comes when I expand the data engineering layer. Other than this layer, you have additional this layer, right? We talk about extract, transform, load. We talked about data security. We talked about availability of the data. That's the complexity that we bring to the table. And with that, what happens is, as I showed initially, how do you build the software? We need to get into this. We need to get into the practice of the next generation software development. So that starts with continuous integration, and then we have a continuous delivery. But the third part is continuous deployment. That is important, right? I cannot say my plant say I need 5 days to deploy this software. It has to be continuous without having any downtime. So that's why bringing the appropriate software engineering skills are also very important. And with the questions. With all these things, you know what the next grand challenge that you are going to face? This is the image of a data center where your data is getting processed. And we heard about ChatGPT, we heard about large language models and all. The alarming part, what we see these days is when we run these models, it's very energy hungry. And it has a massive, massive carbon footprint. And if you don't trust me, trust these publication houses, MIT reviews and all. This is alarming, right? So then my next question before I end this conversation is, what is the next challenge? The next challenge is going to be making AI green. From Shell, we are moving into energy transitions. We are saying that we want to honor Paris Agreement. We want to make the society carbon neutral. But as an AI engineer, AI scientist, this community, our challenge is how do you make AI, first AI green, and then you think about the larger problem. We cannot solve the world hunger. Let's first see if I can provide food to my neighborhood. That's where I want to stop. And thank you very much for being with me.